Hi everyone. In this video, I would like to make another attempt to this problem. But in the second attempt here, I will try to optimize the previous submission. Because the previous submission I'm using O and space. But in here, let's just try to make it in O1 space. Okay, so again, this is problem 230. K smallest element in BST. Alright, so now in my previous submission, I tried to go left, and then maybe when I go left, I go all the way left, and then once there is no more left check, then I consider we have found the smallest node so far. Or in some sense, if, for example, when I first go through the BST and then I for the first time I cannot go to the left child anymore, meaning the current left child is null pointer, then I found the smallest element, and then I go back to the root, that would be the second smallest element, and then the third smallest element would be on the right child. And then I do the same. Basically, I go towards the leftmost, and then go back up, go to the right again, and so on and so on. But the problem is that in my previous implementations, when I go back to the root node, I again attempt to go to the leftmost node. So it means that I am visiting the same node repeatedly until I found the kth smallest element, which is a wrong approach. I later on try to salvage the logic by adding a visited set. So if I have visited a set, then I just won't go there anymore. But this also means that I would have a visited set of size n, and that would cost us O n space. Alright, so anyway, in this video, we will try to attempt it without using the visited set. And we have also explored and found some inspiration from other submissions on LeetCode. So based on that, I will try to come up with a modified version of my previous solution. So let's see what we can do here. I have found that in the other people's submissions, some people are using while loop to go towards the leftmost and then pop it. I don't want to write an exact solution, so let me think of some way to do that. So basically, I'm looking at our sample there. So if we have 5, 3, 2, 1 in the second example, then we pop 1. When we pop 1, we don't want to we want to go back to 2, but when we are 2, we don't want to go to 1 anymore. So how we gonna do that is an interesting question. Let's see. If we keep using while stack, then when we pop the 2, we don't want to go back to 2, don't want to go to the chart anymore. Okay, so another observation here. One, if curve is from pop, don't go left. So if we have pop an element, it means that we have explored the left chart, or I would say the left subtree. So we don't want to do that anymore if we do a pop. But if it is the first time we go to that node, then of course we want to explore the left subtree. Alright then, so I guess we could use a curve variable. So we need to differentiate between whether the current node is popped out from the stack or it is actually the first time we visit it. Okay, so how about like this? How about this? We create a variable called first. Let's see, how about we call it node. So the node is the root currently, and then we input it into our stack, and also we do it into all of the left children until at one point there is no more, then we pop it, and while we pop it, it won't be the we won't explore that anymore. So how about I'm looking at my previous submission, sensing I'm trying to I'm thinking about whether there is a way to modify my previous implementation instead of coming up with a new one. So if I use a while there, so I think I can reuse some of the part of the code there. But let's start with the queue itself. Queue stack. So let's call it trying to come up with a better name. Okay, let's just call it new node. Okay, new node is root. Then we check while stack on new node. Then while new node. Well, new node. Let's see. Okay, I guess you can check if it is new node. Then we are gonna append the left. So while new node dot left stack dot append, first of all we append the new node, and then we append the left. New node equals left. Then at the end we're gonna pop it scene. Okay, I'll just call it scene node. If there is a new node, then we go left, stack dot append. Okay, so if we enter the first if, then we set the new node equals none, meaning that it is not a new node anymore the next time we go to the loop. So if we are not exploring the new node, then it must be something that we pop. So if we pop it, so pop node. So for the pop node, I'm gonna call it scene node. So scene node equals stack dot pop. And then again, I do the same check as my previous implementation. K equals 0, return scene node file, and then the new node will be the right side. New node equals, because we need to explore the right. So new node equals scene node dot right. Okay. So let me quickly go through the code again to make sure I don't miss anything. First of all, I create a stack, and also I make use of a variable new node. So while stack or new node means that something that we haven't explored yet, whether it is the left subtree or the right subtree. So if it is a new node, then we append it into our stack, and then we also append all the left child. In the end, in the next loop, new node would be none, but there is something in stack. So we pop the stack, check it, and then we explore the right subtree, and so on and so on. I think this would give us the right answer, but let me test the code to make sure this works as intended. So the first sample, we have new node, and then stack, then order. So first of all, new node is 3, and then we append it to our stack. So 3, 1, the new node will be none, and then the stack pop one element, and then we put it into scene order, meaning if there is 1 there. The next step, we have new node is the right of 1, which is 2, and then we put it into stack. So stack has no more left child, but we still append itself. And then the next step, the new node will be none, and then we pop one of it. So we got order 2, and then 3. So the next time we explore, it will be none. So we pop the 3 again, pop the 3, and then we found the 3. Stack is now empty, but the new node is now we have 4. So 4 we append to stack, and then the next time it runs, you're gonna the new node will be none. So I think this should work. Now let me quickly put it into LeetCode to make sure it works as intended. So stack equals dq. Then we have new node starting from root. So while stack on new node, let me just call it unseen. Unseen is root. So if unseen, then stack.append unseen, while unseen.left stack.append unseen.left. And then unseen will move to the left side. Then once this is done, unseen.left unseen.left. Wait, hold on. At one point the unseen is gonna be none. Okay, how about this? While unseen, now append the unseen. Okay, so I think it makes more sense now why we see the solution doing this. So while unseen, stack.append unseen equals unseen.left. Now unseen is now none. Now we could call the scene equals stack.pop. Okay, decrease by 1. We then we return scene.fall, else scene equals scene.act to run it. And yep, we got it right. So let's try to submit it. And so we got it right too. Okay. I'm not sure how there is a small memory usage there, but I don't think it matters that much. Because yeah, it's everyone is using a stack. So I think it's fine. Alright, let's stop here everyone. Thank you.